This video was brought to you by Embedded System Solution, a company composed of like-minded electrical engineers, computer engineers, and computer scientists, and whose main goal is assisting our engineering customers, non-engineering customers, and technician level customers with their electrical and computer engineering level and technician level needs. Our customers range everywhere from engineering students to university professors, technicians to engineers, junior engineers to senior engineers. Please feel free to visit us at www.embeddedSystemSolution.com. Again, www.embeddedSystemSolution.com, or better yet, email us at support@embeddedSystemSolution.com. And like always, don't forget to subscribe to our channel and like. Okay. So I went ahead and decided to do the video again, only because I felt that even though the enthusiasm was there every time I did the animation, I was kind of trying to remember why I had created the animation. So I'm doing the video again, so hopefully the enthusiasm is there. And it should be, because I'm excited about this. So anyways, so this particular slide is a continuation of this slide, right? And so as a recap, the computer on the left, that would represent the server, the Git server. Not only the Git server, but it's running Linux operating system. And so on this side, we have the computer on the left, right? The purple computer. So notice how it's purple, and then the computer on the right, that would be the pink computer. That would be what I call the client computer, and there's a reason why I call it the client computer. Yeah, so if you follow it through, that's the computer on the right. So unfortunately, I'm using LibreOffice Impress, and that one's kind of glitchy. So if I were to be using Microsoft PowerPoint, I definitely would have those two images that I want, those two computers, the one on the left and the one on the right, I would have expanded them. And then after I would have expanded them, then I would have removed all the other components like the switch, the other computers, the router, the modem, so the transition from one slide to another, it's more understandable. But in this case, it's making like a quantum leap, in terms of this slide to the other. But hopefully with what I just said, it helps you understand. Okay, because we're only focusing on ports, so that's why we're only showing this, right? And so anyway, so right now we're going to talk about port theory from the perspective of firewall. We're going to talk about firewall, specifically port, the theory from the perspective of Git, right? And so typically, so you have two computers, and in one computer, you have several applications on the server. So let's first talk about the server computer, the computer on the left. So typically you have several applications installed. In this case, in this example, it's just 4 applications, but in a real world setting, you have multiple applications installed, right? And in the server computer, and those applications, either the applications, as will be explained, right? Applications nowadays, they're either standalone or they consist of a server and a client. Standalone means that the application has no need to communicate with the outside world. In terms of the computer, like there's no need for it to communicate. Like, I'm thinking of an example, right? But like in my days, it's just nowadays all the applications that are developed, they develop them to communicate with the outside world. But in my days, like Microsoft Word, at the time there was no need for it to communicate with the outside world. Or if you have Notepad++, once you install it, there's no need for it to communicate with the outside world. GIMP, there's no need for it to communicate with the outside world. So it's a standalone application. There's no protocol necessary. But nowadays that has changed. And so almost all applications, they communicate with the outside world. And when you communicate with the outside world, the application, it's either a server or a client, right? And so in this case, the computer on the left is the server. Now, 9 times out of 10, in a network setting, you designate one computer as the server, and that actually means something. Actually, this conversation open up to a can of worms. If you're a network admin or you have networking experience, this is going to make you cringe, but we both understand what's going on. And what that means is that computer, every single server in the network, again, this is simplification. We're going to put all the server applications on that computer. So example of a server application, obviously, it's a web server, email server, file server. Basically any type of server we're going to put on that DNS server, DHCP server. That's the computer that's going to be designated as the server computer. So it's going to have all the servers for the network. And again, so this is oversimplifying, because as we know in a professional setting, email, web server, and file server, we put it in a DMZ zone. So it's a separate server. So one computer is designated, and that computer is typically a special computer. It's not a client computer like a desktop or a laptop. It's actually a server rack or rack server computer. It's a special computer that's designated to run multiple server applications simultaneously, and it's not unlike a client computer, which is not really meant to run server applications. So just keep that in mind, that it's a really beefed up computer. The server rack, it has a lot of the CPU, 64-bit, a whole bunch of RAM and a whole bunch of hard drives. So it's like a regular computer, but it's a lot more beefed up, and it's specifically made to run server applications. Whereas a regular desktop that you buy at Walmart, that one's meant to run client applications. So there is a difference. Typically, you designate one computer and you install a whole bunch of server applications. Not just one, but a whole bunch. So that would explain what you're seeing right here, and that's what I'm trying to convey. That in this computer, we're designating a server, right? But it just so happens that the servers, I picked them not randomly, but for a purpose. But anyways, so make the assumption that server applications, and an example of a server would be like HTTP server, which is actually a web server, but another name for it is the HTTP server. And so another example of a server is a GET server. Another example is an SSH server. And on this server computer, you can also have client applications. You don't just have to have server applications. So VNC is an example of a client. So that's kind of the reason why I selected the name server computer, because it has server applications, mainly server applications. And so each one of those server applications, because they're accessing the world, each one has an associated port number. And so if you notice, every time you install these applications, these server applications or client applications that have that want internet access, every time you install them, if you notice, one of the questions during the installation process is which port number you want the application to use. And essentially the port number, it informs the operating system which port number is. It informs the operating system as an application which port number it wants to use. Technically speaking, every time you install it, the application can use whichever port number it chooses, as long as another application doesn't already have that port number. And so during the installation process, you're definitely asked which port number you want that application to use. So, and there's standard port numbers that exist and the port number, that's what this slide is about, right? But let's ease into it, right? So what is a port? But just know that every single application that wants to access the internet, access the network, access information outside of the computer has an associated port number. HTTP has port 80, GET server has 9418, SSH has 22, and VNC client has 5900, right? And so probably the $1 million question is, why does it have a port number? What's the purpose behind a port number? The port essentially informs the operating system to which application the incoming frame should be forwarded to, because again, you have multiple applications accessing the internet. So whenever there's an incoming frame, that frame can belong to any of the applications that are installed, and not only applications, but that want internet access, that have internet access. So it's more of the operating system to know to which application forward the frame to. And so probably the best analogy that I can think of is like an apartment complex. If you compare an apartment complex to a house, an apartment complex, the address will represent, like a computer would be the IP address. Every single apartment in the apartment complex has the same address, just like on a computer. All the applications have the same IP address. But in an apartment complex, there's such a thing as an apartment number. Well, just like in a computer, there's such a thing as a port number. So you can have the same address, an envelope going to an apartment complex, but you have to know what within each apartment complex to which it goes to, right? Because there's so many apartment complexes, that's why you have the apartment number. So it's the same thing with a computer. You have multiple applications. Each application has a port. It's like an apartment number, and it informs the operating system to who forward it to. And so, as we'll see, because the frame is composed of information, and the operating system looks at this information, dissects the frame once it enters the computer, the IPS, and in reality, it's the IPS, the Internet Protocol Suite. That's the one that analyzes the frame, and it analyzes it and it looks at the port, the destination port, and it says to the operating system essentially, okay, forward this frame, forward it to this application, and so, which is what you see right here, right? So that's essentially what a port number is. A port number allows multiple applications to use the server, the Ethernet port or the Wi-Fi, whatever you want to call it, at the same time. Hopefully it makes sense, right? But because all the applications have the same IP address, right? In terms of whenever you're receiving the packet. And again, we're going to construct the frame, so this will make sense right now. But just be aware that thanks to the port number, you can have multiple applications accessing the internet at the same time, or accessing the network, accessing Ethernet, whatever you want to call it. And that's the main purpose of the port number. But there's more to it. There's definitely more to it. And especially if you want to know about firewall, because if you're learning ports, you want to learn firewall. So you have to master port to master firewall. And there's more to this. So please be patient. Don't. So anyways, so that's what the port does, and it informs the operating system to who the frame goes to, informs it. But the operating system intercepts the frame, and it analyzes it and says, oh, this is the port number, I'm gonna send it to this. So anyway, so the client application receives it, right, and does what it does with it. Now, the port, the server computer is something that's new to you, but the client computer, the one on the right, that's something that you've probably been used to since beginning. You had several applications. Again, these are laptops that you buy at Walmart, and so they have client applications and mainly client applications. And the nice thing about client applications is that you don't have to configure them. You just download them and that's it. The person that configures them is the person that created the server application, the counterpart. So the web server, designing the web server, the Apache, the website, that's a little bit hard, but the client, it's to download the client and use it, it's very easy. So this is kind of like maybe a shocker in terms of what you've been used to all this time and what is actually exists, right? So anyways, so for every server, there's a client counterpart, right? If it's a standalone application, then no. But if it's an application that requires network access, there has to be a counterpart. And so that's what we're trying to show. That's what I'm trying to convey right here. That, hey, there's a client counterpart. And so in the server computer, you have server applications. In the client computer, you have client applications. And HTTP client is just a browser, Mozilla, Firefox. That will be an example. And everybody has experience with that, correct? And so you have several client applications. And just like the server counterparts, they too have a port number. Every single client application. And what that allows is, with one single Ethernet connection, one single network, multiple applications can share it, right? Because the operating system, that's how it knows to who to forward the packet to, right? Based on the port number. And so that's the important thing of the port number. But again, there's more to this, right? Because you have to, don't click away, because trust me, there's more to this. So anyways, so typically the way it works is the client computer, like in this case, the browser. Let's suppose you're Googling yahoo.com, right? And so the client, the HTTP client, the browser, it constructs a frame, right? And technically it's not the application the one that constructs the frame, it's the IPS, but for right now, for simplicity's sake, let's suppose it is the client application, right? And so the client application wants to construct a frame to send this message to another computer, right? In this case, the server computer. Now, the frame consists of a source IP. Don't click away. This is important. I know it's boring, but electrical engineering, network engineering, it's boring as it is a subject. I wish I can, but don't, because I know this is a boring part. But come on, hold on.